Welcome dear viewers to the video on direct compression technology. Among the granulation technologies like dry granulation, direct compression and wet granulation, the direct compression technology is preferred for some of the molecules to formulate into tablets and capsules. As the DC process, that is direct compression process, saves the time and production cost, and some advantages and disadvantages are there, some limitations are there for direct compression technology. We will see the direct compression method or process in detail in this video. So generally the granulation technologies like direct compression, wet granulation and dry granulation is performed for tablets and capsules. Also for the granules and powders which are required to be filled into sachets. So mainly in the pharmaceutical industries on the commercial scale, the granulation technologies like direct compression, wet granulation and dry granulation are used. Wet granulation may be FBP base or RMG base and can be done as aqueous or non-aqueous. Dry granulation involves the use of roller compaction to make the granules, and slugging is also a dry granulation process in which the slugs are prepared for the powder blend and then these slugs are broken down to get the granules. So slugging and deslugging was the earlier process for dry granulation. Nowadays slugging is not used for many of the molecules, and that slugging process is done by roller compaction. So whenever dry granulation is done, that time roller compactor is used. So dry granulation has the advantages of that it doesn't involve the use of solvents, and also because of that the drying stage is not there. So direct compression and dry granulation like RC and slugging are the preferred techniques for tablets and capsules. Generally the granules are prepared to have the processability of API and raw materials. Also granulation process is done to improve the density, flow, to have the good content uniformity and tablet properties for the manufacturing process. Granulation involves number of steps, but direct compression is a very simple process and the process steps are very less. Now we will see what is the tablet composition for direct compression. So API will be there, that is drug substance. Diluents will be there to make up the required bulk and also to formulate into the tablet. So DC grade diluents are used for direct compression purpose, and these are mainly the lactose, mannitol, dicalcium phosphate and microcrystalline cellulose. Lactose, mannitol, DCP and MCC. Many others are also there, but as a representative I have taken here lactose, mannitol, DCP and MCC. So always remember, whenever you are going to select the dry granulation by direct compression or by roller compaction, you should select the excipients which have good flow and have good bulk density. Otherwise, during compression, the die cavities will not be filled uniform and there are chances of weight variation. Then dry binders are used like HPC, povidone, copovidone and other can also be used. Disintegrants like cross-carmellose sodium, sodium starch glycolate and cross-povidone. Glidants like talc and collidant silicon dioxide. Lubricant like magnesium stearate and others are also can be used, like sodium the SSF is there, sodium stearyl fumarate is there, calcium stearate is there. These can be used, and if the formulation is ER type of formulation, then release controlling polymers are used. These release controlling polymers can also be uh, checked for availability in DC grade or granular grade so that flow will not be hampered. Then coating materials. If the tablets are film coated, then coating material involve the use of HPMC base and polyvinyl alcohol based coating system that may be aqueous or non-aqueous depending on to the formulation. So process steps are the shifting of raw materials, that is API and excipients. Here I have shown the shifter. This contain the sieve and the materials are shifted through this shifter. Then blending and lubrication is done. So this is V blender, this is octagonal blender. In this blender, the material is filled and then it is blended and final lubrication is done. After that, the lubricated blend will be there. So that can go to compression for tablet formulation or capsule filling for capsule formulation. Sachet filling can also be performed depending on the product. Then the last stage is tablet coating if it is required, and the packaging. Packaging may be in the bottles or blisters or strips. So this is the general manufacturing procedure for direct compression. Now what are the CMAs and CPPs for DC process? Direct compression process has some criticality, and that's why it is very important to consider these critical aspects. So CMAs of API and excipients. These are particle size distribution, bulk density, flow properties, hygroscopicity, and others which can impact the direct compression process. Then API load in the formulation. So what is the API load into the formulation? If your tablet weight is 200 mg and API is 100 mg in that tablet, then you can say that the API load is 50% in the formulation. But again, the API load will depend on the API flow properties, API density, and API PSD. Generally, 5 to 10% load is taken for the DC process. API load into the formulation can affect the flow and the uniformity of weight during compression and capsule filling. Blending and lubrication. The blending and lubrication is required to be optimized. Occupancies in the blender are required to be optimized, and then it should be taken to the bigger scale. So blending RPM, blending time, lubrication RPM, lubrication time are the important parameters. Hygroscopic nature of API, excipient and blend. If any of these excipients or raw materials are hygroscopic in nature, then during the processing and storage, the material may get the moisture absorbed and then the flow properties may get hampered. That's why hygroscopic nature of API, excipient and blend is required to be studied. Then is the hold time of blend. If you have prepared the blend and now you are going to hold it for some time before compression or capsule filling, then the segregation may happen. So hold time should be less or should be optimized based on to the formulation characteristics. So hold time should be shortened. Blend uniformity and content uniformity. See, generally whenever the blend is prepared, that time blend uniformity samples are taken and that blend is hold for some time before compression. Now you can assume that if you have done the blend uniformity and it is passing, but the content uniformity at compression stage is not passing. So that may be due to the segregation and also due to the decreased flow of the blend. So hold time should be evaluated in a proper way. Blend uniformity and content uniformity should be a checkpoint for the blend flow and segregation. Now we'll see the what are the advantages of DC process. So as DC process doesn't involve the use of number of steps, the shifting, blending, lubrication and compression are the only steps. That's why the process steps are less. and because of this, the yield is good compared to other processes like wet granulation in the production. Then it saves time and manufacturing cost. As the process steps are less, the time will be saved and manufacturing cost will be saved. Also, documentation will be less because of the less processing steps. DC process can be used to improve the stability of the APIs or drug molecules which are sensitive to heat and sensitive to moisture. As the direct compression process doesn't involve the use of solvent and use of drying technique, that's why the stability of the APIs which are heat sensitive and moisture sensitive can be considered for DC process. Rapid disintegration and dissolution can be achieved. Generally, these DC formulations involves the use of diluents which are DC grade. Binding is not given as like in RMG based granulation. That's why the tablets disintegrate rapidly and the dissolution is rapid. Very rapid or rapid dissolution can be achieved. It can be used to manufacture the tablets or hard gelatin capsules. Also, DC process can be used for sachet filling. One of the important thing here is to understand that the low dose and potent APIs can be manufactured or can be formulated by DC process. As the number of steps are less, that's why loss during the process can be minimized and the low dose and potent APIs can be handled. Then what are the limitations or problems with the DC process? Low dose formulation though we are manufacturing, but still there are some problems. So API load can affect the blend uniformity and content uniformity. If API is present more than 70% or 80%, and if that API is not having good flow, then DC process cannot be selected. Chances of segregation and weight variation. As the materials are not processed, there is no control onto the granule size or particle size, because this particle size alteration is not there in the DC process. Whatever the input materials are taken, the material particle size will be same. But in granulation, you can select the granule size so that the segregation can be avoided. But here in DC process, always there are chances of segregation and weight variation. Then hold time period may lead to loss of flow properties and segregation. If hold time is not evaluated properly, then it may lead to loss of flow properties. Also, blend uniformity will not be good and segregation may happen during this hold period. So this is the limitation. Then hygroscopic APIs can lead to problems in the flow. If you are using hygroscopic API or any raw material is hygroscopic, and if you store these materials for longer time, then the material will absorb the moisture and their flow will be hampered. Density differences in the API and major excipients. So if there are density differences between the APIs and the diluent, so these density differences will lead to segregation, improper flow and problem in the content uniformity. Binder distribution problems. If you are using the dry binders and for example that binder concentration is 3 to 5% around, so it is difficult to distribute that binder properly. Then API is not processed in the DC process. If the API solubility is required to be increased by wetting or by use of binder or by dissolving the API in some solvent, so that processing is not here. As such API is taken into the process, so the API properties cannot be altered or changed. Sometimes the API is processed in the wet granulation or top spray process, or API suspension is prepared and that suspension is loaded onto the dry mix blend. So that cannot be done in DC process. Due to DC process, static charges can get developed and dusting problem can be there because of the no control onto the API particle size or API properties. Then what are the best practices for DC process? If the molecule is sensitive or if it get degraded due to the heat, moisture or solvents, so that time some best practices are to be followed. So always check the API and excipients bulk density, particle size distribution and flow properties, and also have a control strategy in hand to control these parameters strictly. Otherwise the variation in the PSD and BD and BD means bulk density and flow properties, that time the product may behave differently. Always try to select the DC grade excipients because these are the excipients which are mainly researched and manufactured for direct compression. These DC grade materials have good particle size range and have good flow, so these can be selected. Bulk density of API and the excipient, so always try to select the excipients which have similar bulk density like API, and that is to be done on the basis of API load. If API load in the formulation is only 5% or 2%, then you can directly select the direct DC grade excipients and you can blend the API with these excipients. So if API content is low in the formulation, that time API properties will not have much impact. Also consider the BD and flow properties and particle size distribution of the major excipient like diluent. If you are working with microcrystalline cellulose and if microcrystalline cellulose makes the 80 to 85% of the formulation, then you have to control the microcrystalline cellulose CMS very strictly. Then blending and lubrication steps are required to be optimized and studied in detail with blend uniformity samples. So RPM and time of mixing should be optimized. CMS of raw materials are required to be controlled in a control strategy. Major diluents, bulk density, tap density and PSD is required to be controlled. Glidants and lubricants should have proper CMA controls like PSD and specific surface area. Also, the functionality related characteristics of the glidants and lubricants should be studied. Then check the water content and water activity of blend and tablets. So this will help you to understand whether the composition is hygroscopic or not. Sometimes the API is not hygroscopic, but the excipients may absorb moisture. So that is required to be understood and studied in a detailed way. Then hygroscopic nature of API, excipient and blend. If hygroscopic nature is there, then control humidity during manufacturing and in-process storage areas. Also have a in-process storage pack. Store with silica gel pouches so that moisture can be absorbed by silica and the product get protected. Pack to protect from moisture uptake. Hold time of blend, avoid long hold time as to prevent the segregation. Blend uniformity and content uniformity. We have to check blend uniformity and content uniformity as an in-process step. So blend uniformity is required to be controlled and checked as an in-process test for blend, and content uniformity as an in-process stage for compressed tablets or capsule filling. So that is driven through the stratified sample. Critical process parameters are blending time, total number of RPM, blending speed and order of addition of the raw materials. What you are going to add first in the blender, what you are going to add at last, that will also matter. So sandwich blending can be performed in which the API can be co-shifted with excipient, and at initial during order of addition add the 1/3 amount of major diluent, then add the API, and then add the remaining material followed by the remaining quantity of diluent, so that blending should be proper. Then loading and unloading should be critically performed. If unloading is not proper, then during unloading the segregation can happen. Packaging of in-process and finished product. So packaging should be such that it can protect the in-process material and finished product from the moisture. Then if the product is film coated, for example it is for a tablet, if it is film coated, then you can go for aqueous or non-aqueous based film coating. One thing here to remember is that if you are using the DC process to avoid the contact of water with the API, then film coating cannot be done by aqueous. That means water cannot be used at film coating also. So go for non-aqueous solvents and do coating with the organic solvents. So this thing is required to be understood. Otherwise, at one time, one place in the development report, you will say that selection of DC process was there because of the moisture sensitivity of API, and after that you are doing the aqueous coating. So these things should be avoided. So this is regarding the direct compression. As the direct compression process is less time consuming, it is requiring less manpower, less documentation, less processing steps, and it is giving good yield. So direct compression process can be selected for many of the formulation, but always have the clarity on API properties, API sensitivity, and the excipient properties. So this is regarding the direct compression process. Let's meet soon with another informative video. Thank you.